Um, Good morning, friends. I would like to welcome to my educational video. Today we'll discuss something interesting. Just follow me. Uh, you can access my blog from test.net.in, and then you click this blog options. It will open. And today we'll talk about equilibration time. This sheet is protected, so you may need the passcode to operate this. So click this code. Um, and the password you mention PALASHDAS, which is my name, Palashdas, without any space, and all are in small font. So enter. So now you will have a page could able to see about the equilibration time. And to access with the program you need to click here. So once you open, it will show you this kind of interactive window. If you need to understand about equilibration time, you may access to my link of previous video. It has explanations about the equilibration time, and I will make a separate video for this. This video is only to show how this program work. So click this. So it will open to your Cloud AI window. It's an artifact created by me. So you see a black screen with the temperature and time um, line here. uh, you have three window here: monitor, configuration, and theory. So monitor will show you the current state of the cycle what you run from here, and you could able to reset always from here. So this is again two tab. This is for the full cycle where you see the full length of the cycle, the full graph. And this is called T2 focus. T2 focus will focus to your equilibrations range. What you see here as a yellowish band here. If your equilibrations is more, you see the band is expanding and again shrinking. So you could able to set how the band should look like. So this is tutorial purpose. So normally you don't set equilibration upfront, but at this is tutorial, we need to feed inbuilt equilibration time in our cycle, just to simulate and learn how the cycle look like. So this is your live screen, and this will show you the status of the cycle based on the tolerance of EN285. You could able to see end of the cycle what you run. Is that pass, what are the values, it will show here. So normally we'll go to configurations. To configure your cycle, you can set your temperature. What are the set temperature you want? If it is 120 or 120.5, and you see based on the set temperature, you could see the band here, two green lines. This green line represent the sterilization band, which is the set point plus 3 degree. As you know, if it is 121, so your overshoot temperature is 124, so the band will be set automatically here. So, and when you run the cycle, you could able to see whether your heat distribution, heat penetrations, and drain sensor within the band or out of the band. And based on that, you could able to see the equilibration time, how it's look like. So it's quite important you set the band. uh, Here's the chamber volume. You could simulate for the small sterilizer, which is 800 liter, or you could make it for the bigger sterilizer. It's just for example, it does not really make any bigger changes, but as you know, if it is more than 800, your equilibration is accepted more than 30 seconds, and if it is like 800 liter, it should to be 15 seconds or less. So keep your hold time less, otherwise you need to wait till the cycle is completed, or you could drag this as well. So this is for the simulation purpose, so we kept like 300 seconds. Still, we have bit of load mass and noise level. Maybe I will expand this program next time to show how the cycle work in case of increased load mass. But here, this is the indication. It does not really give significant informations, but just for the information. And next one is the failure mode. So failure mode, if you wanted to simulate some failure, because if you set something good and you run the cycle, it will show you very nice cycle. But if you wanted to induce some failure, there is a possibility you could increase or decrease the temperature in your heat distribution and heat penetration sensors, and which you could reflect in the screen. So this is to simulate. And if you wanted to activate the failure mode, you always need to click here, otherwise it will not activate. Even you set, but it will not work here. So, and if you deactivate, you just tick off. And this is bit of theory. You could able to read and understand how the software operate and what are the range it's operate. You could read that as well. So let's run the cycle based on the parameter I set. Click run. You see our temperature start from 100. So normally we don't see the graph below the 100. So means our sterilizer is warming up. Now we are getting close to 100. So we'll see three dots, like three lines. One is represent the drain, one is represent the load, and one is above the load. So normally we could able to see three dots, and you see based on the equilibration time, it shows T2 value at the bottom, which is 28 second, is our equilibration, and the hold is started here. You could see the hold already started. So you could see the equilibration time, and our sterilization hold also started. So it's a nice simulations and learning, because everyone does not have access of autoclave and or the clean room to see how the cycle works. So this is more or less, you could see like the cycle is going on, the sterilization phase. So your temperature is 121.5, what we said, and we could able to see the sensors, how it's working. Your S1 is reference from the drain, S2 is from your article, and S3 is from the distribution. So we see all the sensor, how the temperature is going on. Something similar you could see in sterilizer when the cycle is running, and it's calculating the minimum and maximum temperature as well based on the run. And you could see the holding time it's simulating. We keep it short, so it close quite fast. You don't need to wait for that, but it's quite interesting to see how the simulation is. Meanwhile, it's calculating all the delta values here, and based on that it will show the cycle status as well. So we just need to wait till our cycle is completed, or you could drag this one to finish it quite faster. So you see that temperature is getting down, and our cycle is completed almost. Few seconds. Because see the bar is moving, means our temperature is getting less than 100. Normally you don't see within the screen that value, so still the cycle is going on. So you could see our cycle is completed, and it shows pass, and it shows everything like our equilibration time, which is 28 seconds, what you see here. And the sterilizer is quite big, so the acceptance is 30 seconds, so your equilibration time is well within the limit. Then you see your T1 temperature, T2 temperature, T3, and TB. TB is your sterilization band. As I told you, this is two line, and the band is like set point plus 3 degree. This is within the band. And I will come back to my other video, T1, T2, and T3, how the time are being calculated. Otherwise, this video will be quite long. But if you want to more understand about the calculations, you must look at my next video as well, where I will explain this equilibration time with EN285 graph. So there's one more options, as I told, focus. So focus will focus to the T2. T2 is your equilibration time. But friends, remember, whenever I talk about all the explanation like S1, S2, S3, T1, T2, T3, it's very closely connected with the discussion of equilibration time in EN285, and I use the same parameter, same indication. So you must read the equilibrations time uh, in my blog, or you could read from EN2FA as well. But just wait for my next video, where I will connect that part as well. So as I told, the orange one you could see at the down, this is from the load, so it is bit lagging behind, and this blue, sky blue one is from your drain sensor. So and this The violet one is your load sensor, and you could see it's went bit far, and it's allowed actually in 60 second, in initial 60 second, your distribution sensor could go your set point plus 5 degree. So you could see it exceed the band actually, and it's acceptable in initial 60 second as per EN 285. But it went back, and then it in a quite nice flow, it within the band after 60 seconds, so it's okay. And you see that difference between uh, your sensor within the load and the reference point in your chamber, which is drain, and which is come up within 28 seconds, and it's the cycle is passed because it is still less than 30 seconds. So this is quite interesting. I show you in zoom. You could zoom out as well. This is all about tutorial, and I talk about failure mode. Maybe I will quickly try to show you some failure. I will add bit offset which is more than 2 degree maybe. Let's see how it's work. And you run something from here, and I just fast track the cycle dragging this one. So you see, like this is the distribution jumper which is out of the installation band, and based on that you see it's failure, and the cycle is not really acceptable. So friends, just try and play with this. Maybe before I close this video, I will show you the um, definition of equilibration time: the period that lapses between the attainment of the minimum exposure temperature at the reference measurement point, typically it is drain, and the attainment of the sterilization temperature true at all the points of the load. And we have an indicator from the load as well. This period means T2 in our case, um, is an indications of the ability of properly remove the air and heat the load items. Consequently, it is typically only the evaluated by placing heat penetration probes in the porous and hardwood loads. So we must remember, whenever we talk about equilibration time, we are talking in respect with porous and hardwood load. Don't really confuse with your liquid loads. I have couple of questions and clarification between the lag time, but lag time does not really uh, used here. Here we use the equilibration time. So maybe I will come back in different video where we talk about lag time or other stuff, but not this video is very specific to the equilibration time. I think you like this interactive model. You have everything, just play with this, and don't forget, when you use the failure mode you should tick off, otherwise uh, you will see bad cycle always. And if you want to fast track, you could fast track with that, or if you wanted to wait till the end, you must wait. So if you drag it at the end, maybe it will show you pending simulation. If you want this application work properly, I think you need to wait till the end, then it will show you pass. Like you can drag it, and you can, but you need to leave it if you want to have like full applications work, and it take like few seconds as you set in your configurations how much hold time you need, or you could reduce if you need uh, more faster way the results should appear. I think it's quite helpful. It took me a time to make this kind of interactive window. Hopefully you enjoyed playing with this. I will make a bit of more theoretical videos about the equilibration time, and I will explain the graph as well. But just follow my YouTube channel and wait for my next video.